Hello everyone, we're Team Krompton and are back once again this year trying to solve the eminent problems caused by disasters. The problem we're targeting doesn't really predict these disasters, but in fact just prevents them and more importantly, mitigates their risk. The problem statement that we've chosen this year revolves around floods. About 32 million people every year are affected by floods, and India accounts for one fifth of the global deaths caused by them. Now, this is a statistic that one should not be proud of, and more importantly, we drew inspiration from this problem statement and pondered upon the probable reasons there could be for the same.
Now let's discuss the reason for the aforementioned problem, which is bad planning. We have excess of rainfall, dams being overflooded, and the water spills down. There is no proper pathway for the water to flow out except the riverbed, which was probably dry before this. Now, here comes the main problem. Our municipal corporation have not been able to identify the importance of buffer lands, which serve as the lungs of the city in cases of such distressful situations. Due to this, land is allocated along the riverbeds, and in fact, at some places, parcels of land have been allotted on the riverbed itself, making it one of the most prone areas to such a natural disaster.
We think municipal corporations need a tool or some sort of portal wherein, given the topology of the land, they can easily estimate the critical points in a city which are the most prone areas to flood in case water overflows or excess rainfall happens.
So let's get started with the demo. Here we've made a 3D terrain analyzer which we can fill with water and observe the critical areas as well. There are various parameters which we can tweak and in order to analyze how the flood affects a given area given the topology of the land. We have various features in which we can create mountains, we can create dams, we can simulate all the sorts of land terrains that there exist. Then we can flood a particular area with water like we'll show you over here. So once we start adding water to this encatchment that we've made, water starts flowing. Now notice the critical areas. For example, the lake over here that we've simulated fills and is the first one to fill over here. Thus, this is not a suitable land that can be allocated for human settlement. This area over here is again a critical area because of the huge slope and the gradient near the hills that there are. We gradually notice that the water reaches where it has. Now, such a web app would thus highly be beneficial for authorities to isolate and, in fact, understand the parcels of land which are most prone. And one interesting feature is that we've also taken care of how much time it would take for water to reach and flood a particular place. This is useful if we want to estimate the time it would take for emergency services and rescue operations to reach it. Thus, we would be saving millions of lives by doing so. We can also simulate the flood nature by increasing the amount of water that there is and similarly draining by resetting the flood rate to zero and vice versa. So this is a quick and brief demo of our application, which can be found out on cfdiitj.azurewebsites.net.
Now, let us discuss the impact that a potential solution can bring about. According to NCRT, the density of human settlements around the rivers on an average is about 400 people per square kilometers. Considering the Kerala flooding that happened this past year, if proper mitigation measures are taken, as highlighted in our application, if we save lives in a 500-meter radius on both sides of the river, the number of lives that can be saved shoots to about 97,000. If we assume that a solution saves about 4 out of every 5 lives, the potentially saved lives can cross over 80,000. Now, just imagine the number of rivers that spread across the country. Needless to mention that cost of one life is immeasurable. So come help us develop this noble solution even further. In the end, we would love to thank Microsoft to enable us to come up with such a noble idea. We would also like to propose a vote of thanks to our esteemed director, Sir Dr. CVR Murthy, without whose guidance this project could not have been possible.